Hello world, and in today we are going to actually give let the enemy stop when it reach some distance to the player, so the enemy can finally shoot the player. And also we are going to give our player a bullet so that where we can easily shoot the enemies. So right now what we are firstly going to do is we are going to go to the enemy scene, click on this little script, the script icon right here, and now we can begin modifying the existing code. So I'm actually thinking about the method that we can use. First of all, let us try to check out the distance to method. Let's see how it works out. Distance to player dot global position. Okay, let's go ahead and run our project. Okay, that is completely weird. I'm not sure I have any idea what's going on. So let's go back. Okay. Oh, oh God. Sorry. This was actually meant to be distance too. I have no idea what's going on. Sorry, sorry guys. Okay. Let's see if it actually reaches zero when it touches the player, and bam. Okay, if you look at this very well, I think a value of 100 will be okay. So we can easily go ahead and check for it. So if our global, if the distance between the enemy and the player, if it's less than no, if it's greater than some threshold, I'm really sorry for my slow typing, guys. Um, give it 80, no, or let's make it random. So to generate a random number between a random integer actually between one number and another, we can easily use the random range function. So we pass in the lower the starting range, which is 80, and the ending range, which is 100. So let's go ahead and try this. Okay, and good. Now actually this is exactly what we want, so we can go ahead and increase the value a bit, maybe 50 or 60. Let's leave it at 60. 60 will be perfectly fine. I think you can easily change this to exact any value you want, any value you'd like, but I think that should be okay. Let's increase the speed a little bit. Okay, now let's make some changes to the enemy, and we also get introduced to some new nodes. First of all, we don't want to be following the player every time. We want to be following player, because we are following the player every time. That's okay, seriously, the code to even follow the player every time is not currently added. So let's go ahead and copy this with Ctrl C and paste, Ctrl V. Let's ensure that we paste this above this condition over here. Okay, now what we actually want to do is that we let us test this first to see if it works correctly. Okay, okay, now this works correctly, perfectly fine. But we want some interval between the chasing, so we don't want it to be like that. We want some interval. So first of all, let's use the node that we've explained, that the node is used for grouping. Let's use this to group what new nodes that we now call the timers. So all the timers will be added as the child of the node. So let's add the timer node. A timer node is, just think of it as a countdown, and when we've count down whatever time we set, we can easily get when the time reaches zero, using what is called signals in Godot's engine. So I will explain signals later on, but for now let's go ahead and change the time to like 5 seconds, because what we want is we want the enemies to be chasing the player every 5 seconds. We can actually even change this from the code so that it is random, and it is not fixed, so that we will have some dynamic enemies. So let's go ahead. First of all, let us name this node timer node. Chase time. Okay, so in the ready function, let's call the chase time dot wait time, which is the same with the properties over here. Let's see it. Let's overwrite it. The time required for the timer to start to end in seconds. This property can also be set every time start is called. So wait time equal to, now we want a random number between 2 and 5. We can, if we want the timer to start automatically, we can check this auto start button over here. If you want it to run only once, we can check the one shot over here, but we don't want that. We want it to be running every time, so that we can easily change the direction over here. So now what we are going to do is we are going to start the timer over here. Just time dot start. and now we want to know when the time finished. So let's say that it's like 3 seconds, it becomes 2 seconds, it becomes 1 second. But when it reaches zero, sorry, when it reaches zero, we want to be aware of that. So we can easily use signals to achieve that in Godot engine. So let's go ahead and click on this node over here. Instead of the groups that we use to assign our player to the player groups over here, we are going to click on the signal. So let's like the signal that we need is the timeout signal over here, and you can easily connect a signal to a method. So a signal connected means that this function, so a method, this method or function will be called when when the time runs out. So in our example, let's say 3, 2, 1, 0. Immediately after the timer reaches zero, Godot emits the signal via, which is the timeout signal. But we've already connected it with this function on chase timeout, so we can easily check it out over here. Let's see, print time to chase. Okay, let's go ahead and check this out. Okay, now let's look at our output tab over here. You can see that we are getting time to chase printout, some uh some equal interval. So we can see that the interval are even. So like we don't want the interval to be changing. So if you like, you can easily change the wait time as we did over here. You can change it over here, but we don't want that for this tutorial. We want each enemy to have their own unique chase time, and we want that chase time to be constant. So what you actually want to do is, you want to only when the chase time signal has emitted, that we actually want the enemy to chase the player. So let us paste it over here and let's test this out. Okay, now we're getting some very cool bits. I like this. Okay, it's coming back. Wait for it, and there you go, there we have it. Okay, now let's make some few changes to the enemy again. Okay, let's give it some minutes. Pardon my very old PC. I'm really sorry. Okay, what you actually want to do now is, you will notice the enemy, you will notice that If the enemy runs out or from the screen, uh, we don't actually see the enemy anymore, and we don't want that. We don't want the enemy to leave the screen and just disappear from the screen. What we want is that if the enemies reaches like outside of the screen from like this place over here, we want the enemy to teleport back to the screen from here. The enemy leave the screen from the top over here, we want it to teleport to the bottom over here. So let's go ahead and do just that. So now what you are going to do is like we are going to I'm coming. First of all, let us try this. We're going to be using cloud. Okay, I think, wait a minute. Yeah. I think it's wrap. You can easily check it out over here. Wrap. Godot actually have a built-in documentation which is very helpful. So you can see that we don't even need to visit our web browser to check out all these documentations. We easily get it directly from the Godot engine, the Godot editor over here. So let's read it. Okay, this is exactly what we want. Wrap difference variable between min and max can be used for creating loop-alike behavior or infinite surfaces, which is exactly what we want. We want the enemy to kind of like be looping around, so we don't want the enemy to go off the screen. So let's go ahead and position. Actually, we are not going to just use it as a vector. So let's go ahead and do this instead. So what's the main value? That should be 0. And what's the max value? That should be, don't forget, we have our project setting, we have our window, we have this width. So that should be our width, which is 640. 640. The same thing for the y position. And that's 320, because our dimension is 640 by 320. So let's go ahead and test this functionality. Okay, wait for it. Okay, but actually this isn't the perfect solution for it. We don't want this at all, and we will actually change this later. So but for now we'll be fine with this. So let's go ahead and change the player also, the player script. Let's go by here, click on this. Okay, now the first thing we actually want to do is, let's go back to the preview of our game. You can see that if the player goes off the screen, we are actually not seeing any player anymore, and we don't want that. So we actually want to limit the player movement to some certain amount, so that we can actually just very close to the right like this. We can't move beyond this. we don't want to move beyond this and stuff like that. So let's go ahead and do just that. So instead of using the wrap function that we use for the enemy, we are going to be using the clamp. So what this clamp does is that it limits the position of our enemy. So let's just go ahead and create it by a clamp. So we'll first pass it the value we want to reference, which is our position dot x, the x position, and the minimum value, which is 0, and the maximum value, which is 640. So let's go ahead and do the same thing for the y position. So our minimum value for y position is what, which is 0, yeah, 0, and our maximum is 320. So let's go ahead and try it out. Okay, now let's fix a lot of things in our game, because we don't want a very a not so good game, and this is an example of a not so good game. But before we continue, I want to explain some certain things. If we look at the enemy scene, we notice that we have this little plus icon like over here. Okay, I'm not sure if you can see it very well, but if you are following this tutorial, you would have already seen it by now. So this, you can see that as we move the enemy, the icon also moves with it. This is because this little plus icon over here is actually our scene, or let's just use the node, our node's center point. So this is actually the the main point of our node. So that this is why when we are writing this code over here, that you should clamp it to 0. What is actually clamping to 0 is not from over here. Oh, sorry, it's not from over here, over here. But what it is actually considering is this dot at the center of our node over here. I'm not sure if you can see it, but if you are following along this tutorial, you have already noticed it by now. So what you actually want is that you want to take note of this. My go-to way of doing this is just to have like a size. Okay, it shouldn't be, or wait, I'm not sure if the vector should be constant, but maybe our size is 32. The size of our sprite is 32 by 32. Okay, good. And now let us offset this value. Shouldn't be minus, should it? Yeah. What we actually want, what we want to do with the code is that for when the player want to change the player uh, origin point, but not in a sense, because we won't actually be changing the player's origin point over here. What we'll be changing is how, where we are detecting uh, where we want the player to actually like stop. No, the clamp function actually does just that, to limit a value to some certain amount. That's what the clamp function does. So now what you're actually going to do is to limit it, so that instead of the code to be considering this place, the code will now be considering this place, which is exactly what we want. So what you're actually going to do is to add, this is 0 0 over here, to add half of our player sprite, the size of our player sprite. So let's go ahead and do just that. You can easily multiply it by 0.5. It's the same thing as dividing it by 2. Okay, that's for this side. The next side, which is over here, what we actually want is we want to also shift it to the center points over here. So instead of adding to it, we're actually going to subtract the half of the player size. Excuse me. I'll be back in a jiffy. Please. I'm so sorry for this short interruption. Okay, now let us continue with the tutorial. So wait a minute. I actually want to check out something. Hopefully, I think I've made some silly mistakes over here. Okay, no mistake, I think. So what exactly is going on? Okay, let's go ahead and do exactly as we are, with as I've explained earlier, and it should work perfectly. Okay, now we can only move to some certain extent. Okay, this is very good. Okay, now let's go fix the enemy. The main issue with the player is also the main issue with the enemy. So I won't be explaining things for now. So let's create a let's create our size. Let's make the size of our enemy, which is 32 by 32. So okay, now let's go test out our sim. Okay, maybe not what we want. Yeah. It's a little bit different from what we want because uh, the enemy and the player are a little bit different. For the clamp, that's exactly what we want, but for the wrap function, we don't want that. We want this enemy to leave the screen before it got teleported at the other side of our screen. Okay, let's say that the enemy is here and it already got teleported over here. We don't want that. We want the enemy to leave the screen completely. And don't forget that uh, by adding to our origin over here, that will actually let our enemy to be teleported if it's like over here, if it's touching the edge. So we don't want that. We want it to leave the edge over here completely before it got teleported over here. So what we actually do is to just reverse, do exactly the opposite of the clamp function. So instead of 0 plus size dot x times 0.5, we're going to use 0 minus size dot x times 0.5. Instead of 320 uh, minus size dot y times 0.5, we are going to use 320 plus size dot y times 0.5. So let's go ahead and paste our sim, sorry, again. Okay, perfect. So so good. This is exactly what we want. Okay, this tutorial is getting long. I think we are going to be adding bullet next. So I'll meet you in the next tutorial. Stay safe and I love you guys. Thanks so much for the 100 plus views. I'm very grateful. So bye for now and I'll meet you in the next tutorial. Bye.